Hello friends, welcome back once again in the video lecture series of Introduction of Languages and Grammars Part 2. As I have already taught you in the earlier lectures that this topic I will cover up in two parts because while explaining the examples it can take some time. So let us discuss about power of alphabets. In the last video I have already covered so many things, so many facts and concepts about alphabets, strings and operations on strings. If you skip that video, I have already mentioned the link of that video under this description. So let us start about power of alphabets. What is alphabet? Alphabet is nothing but, that is, you can take like this. So this is the alphabet which is having two symbols, right? Another example we can say that is alphabet that is equals to A, B, C. Here this is also an alphabet, right? Set of alphabet which is having three symbols. So first of all I will try to explain you with the help of two symbols only. Then I will later on in the subsequent lecture I will teach you in deep. So with the help of this alphabet, what will be the power of alphabet? That is 0. This is the power of alphabet. Anything raised to power is known as power of alphabet. So it means that there is nothing on the 0 power means the string will be, no string will be generated. That means the string will be nil or null, not nil, null. So null string can be treated as epsilon or lambda, right? Okay. If the power of alphabet is 1, then what is going to happen? It will be your, how the string will be generated? It can be either A or B. This is two possibility only, right? Okay. Suppose I am taking sigma as sigma square, means power of alphabet is 2. Then what is going to happen? That means we have to take the combination of these two, right? How it is possible? Just see. It can be start from AA, next can be AB, then BA and then BB. That's it, right? Power of 2. It will not go beyond this, right? Next 3. What can be happen with the help of these two alphabets only? So it can be written as AAA. Okay. AAB, ABA, ABB, BAA, BAB, BBA and BBB. So how many possibilities can be possible? There are 8 possibilities, right? Similarly, if you want to go for 4, so it will start from A up to B. So I think so with the help of these two symbols you can well understand about the power of alphabets. Suppose instead of 2 we are having 3 symbols in an alphabet, then how this power will behave? Let us see. So for E0 the answer will be same, that is epsilon or lambda. Sometimes some books are using lambda, sometimes some books are using epsilon. That's why I am using the both cases. But for me, I used to take epsilon only instead of lambda, right? Even sigma raised to 1. That is, it can be either A or B or C, right? Okay. Square means what? Alphabet square means maybe AA, AB, BA, right? BB, CA, CB, CC, BC, yes, BC can be happen, okay? AC can also happen, right? And CC is already taken. So these many things we can deduce, right? So with the help of square we can we can take exactly two symbols as a sequence or as a string. So I think so power of alphabet is quite clear to you. Let us discuss about one important topic, that is clean closure of any alphabet. So clean closure is denoted by sigma star, and sigma star is nothing but sigma raised power 0 union sigma raised power 1 union sigma raised power 2 union sigma raised power 3, and it goes on up to infinity, right? Okay. So how it is possible? Suppose sigma is equals to a. That means sigma is a alphabet, set of alphabet. It is known as set. ठीक है? एक ही symbol है, but still it is known as set. Why it is known as set? Because it is enclosed in the braces. That is why it is known as set. This alphabet is having only one symbol, and through this symbol only we will try to understand the concept of sigma star. So, as in the earlier video, I have already told you what will be your sigma raised power 0. Sigma raised power 0 will be your what? A raised power 0, right? This will be your A raised power 1. Let it be like that. Don't take it is as a mathematical power, right? Next one will be your A square, next one will be your A cube, and it goes on, right? Why I have taken comma? Because here it is union. Union means what? Combination of these sigmas, right? Combination of these sigmas, and ultimately what we will get? We will get different strings, right? So from one string, first string, I will get A raised power 0. That is your sigma. That is your epsilon, right? Comma. From here I will get A. From here I will get A square. That is AA. Triple A. 3 instance of A. 4 instance of A. Right? And so on. Right? So what is sigma star? Sigma star is equals to this is. Right? Let's suppose I am having this is sigma is equals to B. So what will be your, if sigma is equals to B, so what will be your sigma star? So sigma star of B will be your epsilon. First one instance of B, 2 instance of B, 3 instance of B, right? 4 instance of B, and it will go on and on, right? Right? So in this lecture, I am taking very basic concept of your clean closure. Later on, when I will teach you finite automata, there I will take some more combination of more than one symbols, and I will try to explain you about clean closure of those alphabets, right? Next, positive closure. This is also very important in generation of string, right? So sigma plus is known as positive closure, which is equals to first instance of alphabet, second instance of alphabet, that is sigma, third instance of alphabets, fourth instance of alphabet, and so on, and so on. That means if we want to establish a relation between clean closure and positive closure, then what we can do, that is sigma star is equals to sigma 0 union sigma 1 plus sigma 2 plus sigma cube plus sigma 4, right? And so on. That means sigma star is equals to sigma 0 union sigma positive. That is, clean closure is equals to null string union this positive closure. That means, in nutshell, we can say this is equals to sigma positive closure union epsilon, right? Epsilon. So in this way, or we can also write it write it as, that is sigma plus is equals to sigma minus 0, or sigma plus is equals to sigma star minus, this is your sigma star minus your empty string. What is empty string? So many deduction you can make it. This one important deduction, this is second important deduction, is very important. This is the third important deduction. So anything you can take it. This one or this one, right? Thank you. So let us talk about language. What is a language? In the earlier videos I have already told you, language is a set of string which can be accepted by any machine, whether it is finite automata or PDA, push down automata, or LBA, linear bounded automata, or Turing machine. So when a string is accepted by a machine, then that string can be called it as language, right? So whenever we are talking about language, so language is of two types. One is your finite string, it may have finite string, and it may have infinite string. Let us talk about the example of finite string. Finite string can be treated as, like, if I am having say for example sigma is equals to, I am having a comma b, that means I am having two symbols in this alphabet, right? So for this we can have, if I am going for finite string, means suppose at max we can take it as maximum of 2 length, So first can be treated as epsilon, second may be a, third may be b, fourth may be AA, next may be AB, BA and BB. So this is the example of finite string. Why is finite string? Because we have stopped our maximum limit, that this string cannot go beyond the length 2, right? Sometimes we can have the string of infinite length. Say suppose one alphabet is there, suppose it is your C, and here it may be your C star, that means suppose take it as 1, take it as 2. So what will be the union of these two? Union of these two will be sigma 1 union sigma 2. That is sigma 2 is there, we have to take the star. So in this case, what will be the string? String will be your, first will be epsilon, second will be your C, 2 instances of C, 3 instances of C, 4 instances of C, and 4 instances of C, and so on. So here we can have, if we will take these two alphabets for designing a language in which first is having E1, which is having two symbols A and B, and second one is having one symbol as C, but we are taking the clean closure, then it can be possible that this combination of these two will be treated as language. But we should make sure one thing, the language is a string which can be accepted by the given machine.
Okay, so last topic is let's talk about grammar. Why grammar is important? To learn a language in a better way, we should have to learn about grammar. So in theory of computation also we have to learn about grammar, right? These grammars are used in almost all 4 types of machines, but here I will just explain you general format and general condition of grammar. Grammar is represented by G, which is having 4 tuples or 4 attributes. First is V, then T, P and S. V is set of non-terminal symbols. Non-terminal symbols are generally represented by capital alphabets such as capital A or capital B or capital C or capital D, like this, right? Next one is your T. T is nothing but it is a set of terminal symbols. Terminal symbols means what? That string where it terminates, and the strings are generally terminates at small a, b, c, d or up to z, or sometimes we can also take 0, 1, 2, 3 up to 9, right? Next one is known as your production rules. Production rule is the rule which is used for derivation. Like what? Suppose production rule format is x derives y. That means in terms of x, whenever we want to use y, we can use it. That is known as your production rule. Production rule means what? Produce something, right? So for example, a tends to small a. That means in terms of capital A, we can write small a, right? So next example, a, AB. So in terms of A, we can write AB. We can also use A tends to A, right? So what does it mean? It means whenever I am talking about x tends to y, so x means what? It is the combination of V union T plus derives V union T star. What does it mean? It means that in production rules, in x, we must have at least one non-terminal, right? We must have at least one non-terminal, and in right hand side we may have terminal or non-terminal or epsilon, right? So this is the general format of your production rules. That means in left hand side you have to have at least one non-terminal. That means if you are writing like this, A tends to AB, it is a wrong production rule. Why it is wrong production rule? Because in left hand side at least we should have one non-terminal. It may be AA tends to something, or it may be AA tends to something, but here it must be at least one non-terminal. Okay, fine. Next, about your starting symbol. Starting symbol means, here I am explaining, suppose you are having three production rules, right? S tends to say suppose A, S and or A, right? A tends to AB. So what does it means? Out of the two production rules, the first production rule is this one. So starting symbol will be S. So among all the production rule, the first rule will be known as your starting symbol, and normally starting symbol is denoted by capital S. So in this lecture, that is enough to introduce you about a grammar in a very general way. In the subsequent lecture, when I will teach you all the machines separately, then I will teach you all these grammars in a better way. Thank you for watching this video.